I'm Natasha, and
I'm Red.
And together we are Syllogism, a science, culture, and philosophy challenge podcast on the edge of chaos. This season, we'll invite guests of varying expertise to playfully investigate Howard Gardner's theory of multiple intelligences. Each episode will explore a particular type of intelligence according to Gardner. This week's challenge was to solve the riddle, what question is its own answer? This riddle comes from the idea of a computer program which takes no input and produces only a copy of its own source code. This concept, known as a quine, was coined by Douglas Hofstadter in the book Gödel Escherbach in honor of the 20th century philosopher and logician Willard van Orman Quine. Our logical and mathematical intelligence challenge was posed by Noah Healy, a data scientist and mathematician who developed a technology that could, in theory, all but eliminate transaction costs for commodity exchange markets. Now Noah joins us to play with the idea of mathematical intelligence. Enjoy!
Is that your prep? Do you like? Nice. I'm loving the hair. I have the same thing going on. We're kind of right here.
This is like your 11th podcast you've been on, like 5,002.
I think there's about 50 published.
He's got a spreadsheet, of course.
He wakes up, rolls out of bed, goes to a podcast, has some coffee, a little noshing, goes to another podcast.
46 published ones.
Like, holy
wow.
Shit. Well, so Brett didn't get to meet you yet. So what the fuck are you doing going on all these podcasts?
Mostly just describing this CDM system. CDM is a marketplace system. So there's a lot of downstream implications from removing trillions of dollars of cost from operating the economy on an annual basis. And I'm not terrific at writing, so having conversations is a more effective way for me to be able to produce things on a permanent record.
So this fits in perfectly with what we're doing. Looking at discrete types of intelligence. Obviously, what we're talking about here with what you do is a mathematical, logical type of intelligence. But you're basically saying, like, I can't write for shit.
I have a particular form of dyslexia. I've managed to develop my conversational facility, but writing never really came along for the ride. And my brain kind of shuts down in the face of writing.
Interesting. Why don't we start by you just telling us what you do and why? And then we'll go into the challenge from there.
Well, my major activity these days is promoting and supporting people who are actively trying to build new marketplaces using my coordinated discovery technology. The reason I'm doing that is that close to a decade ago, I was working on a math problem for fun and discovered a model of economic exchange that, if you added a computer program to it, would be considerably cheaper and more stable than every kind of economic exchange that's ever existed. And the consequences of bringing that kind of system into general use would be approximately doubling the rate at which human wealth was accumulated.
Just small things, just little things you're doing.
Yeah. Since it's effectively impossible for anything to be more economically valuable than that, it basically constricts the moral framework I live in, because not working on that problem is just wrong. So that's what I do now.
So this isn't merely computation. This is also an ethical and humanistic problem that you're working on.
Well, yeah, nobody needs to care about numbers. Some people do, and it's very fortunate for all of us that they do, because it turns out that they're kind of the most important things we've ever come across. But I'm not really, really smart. I'm just pretty bright. And so I pretty much am stuck with working with things that are applications. And finance is probably humanity's first information processing system. And we're using the same system that we've been using for the last 8 centuries. And in the last 80 years, we've learned an extraordinarily large amount about those systems, including information that has obsoleted the ones that we have, which is why you've seen over the last maybe quarter century a greatly increased instability and uncertainty and greatly increased cost from the markets.
I wonder if you might be able to tell us how it was that things were disrupted about 25 years ago, and then maybe a little bit about how the system that you are working on would improve upon that.
Okay, so we have signal and noise. Every information channel has a certain capacity, and the more noise you put into that channel, the less signal it can carry. And if the entire channel is filled with noise, no information can get through the system. What computers have done is radically increase the amount of information that is being produced. Modern marketplaces have been having a greater proportion of noise stuffed into them. And so that's why market failures are happening. It's easy to point to other specific causes. You know, this thing blew up because the Wall Street bets people all decided to do something at one time or whatever. But the increasing frequency of these things is actually just a systemic problem. If you live in a floodplain, then maybe your house floods every once in a while. If you live in a floodplain that's below a dam that got blown up, then that's, your house is going to flood a lot more frequently. That's where we are.
So tell me if this is correct. If your algorithm works, you could put Schwab, E-Trade, these kinds of middlemen out of business, right?
Yeah, middlemen who are primarily brokers or who are essentially just putting money to work in the market, buffering it, would have no role in my system.
Okay, question. Is there a lag? I think there's a huge lag.
I think there is a bit of a lag.
The way to check that would be for me to talk, and then once I've stopped by saying some bizarre word, let's call it squirrel, then you would talk once you heard something. And if I heard a lag as a result of that, then we'd know you had a lag. Squirrel.
Squirrel.
So yeah, it sounds like there's maybe a couple seconds going
Squirrel.
there.
Squirrel. Yeah. So.
Let's head over to Zoom and see if that works. 5 minutes later.
You guys, this is going to be the death of me this episode. Oh my God. So can you explain how marketplaces work and how and why cutting transaction costs isn't really exactly like cutting gas fees?
If you negotiate a contract, you have to pay a lawyer to actually write that up and check that it's legally binding. That's what's the equivalent of gas fees. The other part of transaction costs is the time you would take to actually negotiate your position with the other person. So that your time has value, that's part of the transaction cost. Another part of the transaction cost is mistakes made during negotiation, where you may have been able to pay less or receive more for what you're buying or selling. That's part of transaction costs too. And so transaction costs is this accumulation of all three of those things. The gas fees are the equivalent of the lawyer bit. Marketplaces address these other two pieces by getting a bunch of people who are all making the same sorts of deals in the same place. Used to be a physical place, now digital spaces mostly, and offering them insights into what sort of deals other people's are making. Then you get a lot of reduction in the amount of errors that occur. And by simplifying those deals so that everyone's making the same kinds of deals, you get a lot of reduction in the time you spend negotiating. And so those costs are shrunk by marketplaces.
What you're saying basically is I got to go to the Chicago Stock Exchange trading floor one time and everybody's flipping around papers. So by putting everybody in the same physical place, everybody could kind of see what was going on and you could reduce transaction fees a little bit there. But now you're talking about a digital marketplace where you can have real-time access to pricing and transactions and everything that's happening there. So that's shrinking the cost more. But what is it about your algorithm that really shrinks the cost?
So what I've done is found a way to measure the difference between noise and signal in the things being sent to my marketplace. So let's say you think that the oil market is too low. It should be a lot higher. Well, what do? You buy oil. And if you turn out to be right, then oil will go up. You'll sell your more expensive oil. You'll make money. What if you think the prices are too high? You sell oil. And if you turn out to be right, then you will have sold oil at a high price and you can buy it back and restore your stock at a lower price or something like that. And once again, you were correct. So the amount of useful information that's in your desire, you either bought or sold, there's one bit of information there. You bought, you think the price should be higher. You sold, you think the price should be lower. But you're not perfect. Nobody is. Maybe you made a mistake. So there's a fraction of one bit of information that's in your desire to buy or sell. And that fraction might be quite small because with computers, people can put in hundreds or thousands of bids simultaneously just in one market. And there's dozens of marketplaces that they might be spreading bids across. So the amount of information that's in the bid is quite large. The amount of signal in the bid is some fraction of a single bit. The amount of data that the Chicago Mercantile Exchange, or the CME Group as they've rebranded themselves, produces on an annual basis is petabytes. Within the petabytes that they generate, each of those signals contains some fraction of a single bit of information. And the actual market ticker represents the good information out of that petabyte.
So what is all the shit information? What is the signal and what is the stuff we don't need?
Effectively, what we don't need is everything ancillary to where the price is eventually going to wind up. So what my system does is it establishes a schedule of trading for the future and allows people to predict where they think prices will be in the future. But we integrate that information from those things that are coming in based on their differences from the existing consensus. And we do it using information measurement techniques that are sort of well known and established, so that people putting in small amounts of information make small investments. People putting in large amounts of information make large investments. But we record what your information values were and then compare them to what the final answer turns out to be, which allows us to extract how much of your communication was signal and how much turned out to be noise. So right now you have a 1-bit option. If you think the price should go up, you should buy. If you think the price should go up a penny, you should buy. If you think it should go up $1, you should buy. If you think it should go up $1,000, you should buy. That's all there is. In my system, if you think it should go up a penny, you should say, okay, I think the price is pretty good, but I think this last bit here should be up by 1. You think it should go up by $1, $1. $1,000 over here, $1,000. So then what will happen is the system will integrate that information. So let's say all three of those guys put in their bids and the price winds up going up $500. Well, the penny guy and the dollar guy are both 100% correct. The $1,000 guy is actually pretty correct as well, but he overshot the mark. He would have, depending on how you're measuring the information, 50 or 70% correctness. The other guys would have 100% correctness because they were all correct that price was moving up and they all moved price upwards. They just didn't move it all the way to where it wound up needing to get to, or they moved it past there.
Okay, so I get it. You're basically turning a system that's a binary into a more graded system. So that smooths it out and gives you better prediction ability.
Absolutely.
Oh, shit. Like that's, right? I guess. So can you explain, this is a question I've had. What are futures? Can you explain this concept to me? Because I don't think I know.
Futures have been around for a long time. Futures are agreements to trade in the future. So these things were all started to move around physical objects, and moving physical objects through space is slow and expensive. And you really don't want to do it unless you're pretty sure that you're going to like the outcome when you do it. So just like growing all the corn in Iowa and sticking it on a boat and shipping it to some port in Europe would be a pretty insane thing to do if you weren't already pretty sure that you were going to sell it for the amount that you wanted to sell it for. Because there's a lot of slowness and expense at every single stage of that thing that you'd have to be absorbing on the hope that when you showed up at the docks at Le Havre, somebody would be there with cash in their pocket saying, oh yeah, I wanted that. How about we make an agreement that I will sell you a boatload of corn 6 months from now for this amount of money, and you take the other side of that. And so now in 6 months, we have an agreement. So what this does is maybe tomorrow a news story comes out and we're like, oh crap, that can't happen. We can now create a second contract where you agree to sell me a boatload of corn on the docks of Le Havre 6 months from now. And now those two contracts effectively cancel out. And if there's a price differential, we can cancel it out with just cash. If things shifted against me, I can pay you some money and then it's all over and I don't actually have to book a ship and grow the corn. And if it against you, you can pay me a little money and then you don't have to buy some corn and get some warehouse space and figure out what you're going to do with this stuff because it's worthless now.
So it's a way of assuring equilibrium in the future.
Yes. And it does another interesting thing. Have you heard the phrase buy low, sell high?
Yes.
Yeah.
So that has a particular relationship to time. You buy something while it's cheap, and then you sell something when it becomes expensive. But that's not the direction that value has to travel in. Sometimes things are expensive now, but they're going to be cheap in the future. So buy low, sell high can't do anything for you in this situation. And if you know that something's expensive now and is going to be cheap in the future, then you can't sell it now because you don't own it yet. So there's no incentive for you to provide that information to the marketplace. But what futures do is, because there's this time dislocation, you can essentially sell something before you buy it.
Okay.
So instead of buy low, sell high, you can sell high, buy low.
So basically, if I'm the corn guy in Europe and I'm like, I know Noah's got this corn that's coming and I know it's going to be cheaper. So I'm going to set up a future to sell it to Brett's dumbass who doesn't know this information. I'm gonna make a boatload of money on it.
So I scanned through some of the white paper early this morning, and what I find really fascinating is that you're taking a kind of humanistic approach and saying we should all maximally profit. And so this is like kind of antithetical to what you see in most of what I would think of as algorithmic space.
That's because they're evil, basically, which is deeply unfortunate that evil people have essentially dominated our social and economic space. But what are you going to do? You've got to just build some stuff that actually works, I guess, hopefully. So algorithms have gained a very bad word association.
As soon as I utter it, I get the creepy crawly feeling. I know I'm talking about something bad that's controlling us in some way. It is the invisible hand, and but it's always evil.
Right. And I think that association is essentially because the people that built Google, Twitter, Facebook, and so on didn't actually think through any of these issues and what the downstream consequences are. And in complete fairness to them, what they're doing is so complicated that I don't imagine it would be possible for human brains to even consider those things in a productive way. One of the hallmarks, I think, is that none of these companies can publish their algorithms.
So what's the can't versus the won't?
Let's take possibly the most benign or possibly the most insidious example, Google. Google's primary algorithm is search. And what they're really about isn't search, it's ranking. Any old fool who has enough disk space can build a spider and read the entire internet. The hard part is, given some text string that some yokel in the middle of nowhere typed into a box, what's the 10 most important web pages for that person to be looking at? And that's a hard problem. But there's a lot of value in having your web page be one of those 10 web pages. And nobody has a proposal for how to create a ranking algorithm that the web page producing community wouldn't be able to adjust their web pages in order to adjust their rankings. And so if they publish their algorithm, then people can now adjust their web pages towards the algorithm and then put things that nobody actually wants to see in front of everybody's face. Are you familiar with something called the one pixel attack?
No.
So there's a thing that you can do after you've trained up an image recognizer AI, where you can train up another AI to figure out how to break the first AI's image recognition. And the one pixel attack is making an AI that can take a picture of something that's clearly that thing. So you have something that can sort of like tell whether or not there's a dog in a picture. And then you take like Lassie's headshot and you give it to the one pixel, and the one pixel goes in and literally changes a single pixel. The human eye wouldn't really even be able to distinguish within that thing. And you hand it to the dog not dog machine, and it says, oh yeah, it's not a dog.
Oh, shit. So I've done a little bit of this stuff with fast.ai. I wrote an image classifier and used a ResNet when I was into this kind of stuff. Basically, this is a program that goes in and infects the original image classifier.
So it doesn't infect the original image classifier. What it does is it figures out what it is that the original image classifier actually cares about. And so that it can change the one thing that it actually cares about to destroy its entire system. And so you can put a filter on that would be so small that we wouldn't really care about it, that would then destroy that algorithm. So if Google or Facebook or Twitter or YouTube or any of these people that do recommendations and stuff like that, if Amazon were to publish their algorithms, that any nefarious person or group that wanted to set up an appropriate system could basically create a one pixel attack.
So give me a scenario of Noah's dreamscape. Let's say these pilot programs you're supporting work out. What happens when CDM is ruling the world, so to speak? What would it look like?
Okay, well, let's use the United States because we got some nice round numbers here. Our economy is 20 to 25 trillion dollars a year, and the smeared out growth rate over the last generation has been about 2% a year. So 4 to 500 billion dollars a year of economic growth. The costs, the transaction costs imposed by the present commodity trading systems on our space were 800 billion about 8 years ago, $1 trillion by now.
Your algorithm would cut that in half.
My algorithm could theoretically cut that by as much as 99.99%, actually 997%, but let's just go with half. So we've now freed up $500 billion a year for the general economy. That can go back into reinvestment and so on. So the growth rate of our economy would go from roughly 2% a year to roughly 4% a year.
Okay, but that's temporary, right? It wouldn't.
Nope, that happens every year from now on. That causes the entire economy to grow. The costs scale with the economy. That $500 billion plus its 4% growth for the following year then feed into that economy. And so that compounds.
But what I mean by that is it's like subsumed. It's like if everybody gets a UBI, for example, then everything just becomes more expensive, right?
Well, so this isn't everybody. This is the productive sectors of the economy. Let's say you're operating a farm. Let's say you're operating a farm at 15% margin. That's a little richer than the average American farm, but that's a nice round number. If you were doing $500,000 in business, then you would be getting about $75,000 a year, which is sort of a median-ish family income here in the States. Your overhead costs from the marketplace would be on the close order of $75,000 a year on average. So this theoretically average farm with those things cut in half would get a $37,500 raise.
Okay.
Forever. So farming suddenly got 50% better as a result of doing this.
What would be an example of an economy that wouldn't be affected by your algorithm?
Pure services, so doctors, lawyers, those sorts of things. The other parts of the finance system would vastly contract because just wouldn't be as much work for them to do.
So you said other parts of the finance system would vastly contract. So like Schwab would want to like murder you. Is that what would happen?
People have proposed that as a possibility.
I can't imagine why anyone would be opposed to adoption. So if the market is automatically, aside from those, crazy people who are already profiteering,
They're not crazy. They're the ones who are winning right now.
they're not providing the kind of value that anyone actually wants to pay for.
They don't
So
give a
if the
fuck.
market were performing better, and everyone participating in that market was also more wealthy, why wouldn't everyone outside of the middlemen who are clearly just, stealing, why wouldn't everybody just want to say, okay, this is how we ought to be doing business? Isn't it obvious that cooperative systems are better? And why wouldn't that just become the default?
Let me
Well-
play neoliberal advocate here. So you've had all
Okay.
these systems in place for, what'd you say, 100 years?
Yeah, the CME group, that goes back a century.
Okay. So we've got systems that, have been functioning as they are for 100 years. And so now all of a sudden, here comes Noah Healy. He's going to save the fucking world. And these people are left in the dirt, right? With every innovation that happens, there is wreckage. This would be the wreckage of this kind of an algorithm being implemented. And so anytime that happens, those companies get bailed out by governmental systems. So would your algorithm require a Schwab E-Trade bailout?
That might be what governments decide to do. It's, I think, important to understand that there's actually more money and vastly more people in the productive sector than there is in the financial sector. The concentration of wealth in the financial sector is vastly greater, but in an actual sort of wealth to wealth battle, the farmers are taking 5 out of every $6 and the financiers are taking 1 out of every $6. But yeah, this has a lot of other implications. There's
It would
also,
eliminate parasites.
they aren't parasites right now. They're only parasites in the light of the existence of a better
Right.
alternative. Where
Exactly.
they're they're no longer necessary.
Like we just found out we have a tapeworm. It was good until you get your medicine for it, right?
Yeah. Yeah. Lack of understanding is, I think, the first and foremost difficulty. I'm good at math. I'm not good at sales. So just figuring out how to get this into the space itself is part of the challenge.
So one of the things that might be beneficial for you is to think about simple scenarios. And if you can do that simply, I think people will catch on quickly.
Well, that's what I'm working on through podcasting.
Yeah, and I see that. We talk all the time, Natasha and I, about how, hey, we're living in a narrative structure. We tell each other stories. This is how we evolve and survive and create civilizations. It's also how we adopt things. So it's the story of the successes that will help people to grasp the message well and then want to work with it.
And it's hard to understand because I have a friend who's a linguist, but he had some shit to say about our last episode. He was like, you guys are just telling stories, your own personal experiences. And I'm like, baby, that's what we do on podcasts. So it's hard for people who are scientifically minded or logicians to draw analogies, parallels, to understand the value in doing that. But I think this is a perfect segue into talking about our challenge, which is to demonstrate mathematical, logical intelligence. And this is why I thought you would be awesome to come on this podcast, because you told me when we were talking, you said, like I've got this algorithm figured out, but I really struggle with getting it out there. And I thought, perfect, because I think that's somewhere where we can help each other. It's what we do.
We play with ideas and we teach each other along the way, because I never know what Natasha might have a couple notes. I might have a couple notes. That's it. The rest is all just pure play.
Yeah. So we're just handling it in real time. So you gave Brett and I a challenge in addition to understanding what the fuck you're doing. You asked us, what is a question that is also its own answer?
So this is an example of something called a quine. Quine's named for an English logician, and a quine is a program whose output is its own content. So if you run the program, it will print off that program. Quines have been exhibited in a number of different areas. There's actually a functional quine. Human beings have worked out a function that, when graphed on the XY plane, draws an image of the characters that make that function up. Every programming language that exists has the capacity to produce quines. And so it's a toy, but it's also a very core computer concept, because one of the most important kinds of programs that exist is something called a compiler. And that is a program that can read a program written in one language and write the exact same program in a different language. And since computers process languages that human beings find it inconvenient to interact with, the way we generally interact with the computer is by using compilers to change the languages that we're willing to use into programs in the languages that they're capable of processing. So a program that can self-produce has a very special relationship to compilers, because most compilers are now written in the language that they compile. And the compiler that the computer runs is the compilation of that compiler by itself.
You lost me.
So if I may ask, what is the application of something that only produces itself as an output?
So purely speaking, it's just a toy and a challenge. But the capacity for self-production is the first test of general production. And so the capacity to do this points towards general computing capacity. And general computing capacity can do quite literally anything that can be imagined.
So human intelligence is like this. Let's say your DNA is almost like this.
I'd say a virus.
So Turing explored full computability first. The system that he described is morphologically nearly the equivalent of DNA. And viruses, in fact, are a key example. So what Turing did was describe this very simple machine that had a set number of states that could move back and forth along a tape that had information on it, and then pointed out that you could write a description for an arbitrarily large machine with an arbitrarily large number of states on that tape. And this simple machine could go along and behave exactly like that arbitrary machine that you were on tape. Those tapes are the equivalent of DNA structures, which are 300 billion sequence 4-digit numbers, basically. And viruses have a set of instructions that they give to our cellular machinery and cause that cellular machinery to behave like a virus replicating device. This was before DNA was even the leading candidate for being the genetic material in cells, and decades before we had any idea what the actual physical structure of DNA was. One of those kind of synchronicity, crazy coincidence type things.
Zeitgeist. So yeah, that's immediately what I thought of was a virus is a perfect example of a biological quine, because DNA can't replicate itself. It requires other machinery.
So the amoeba would probably actually be the ideal biological quine, because amoebas actually twin and create two copies of themselves as one of their primary mechanisms for reproduction.
Right. So that's a biological quine. You asked us to come up with an English quine, a question that can answer itself. And I'm very curious as to what Brett came up with.
Well, my current answer now has shifted a little bit. It's amoeba. That's it.
Oh, okay.
That's it. So I don't think I understood the question properly, because when she sent it to me in a voice, and I was like, okay, well, I would say anything tautological, anything recursive, stuff like that. But I didn't come up with a question. So that's my answer to the challenge is based on very poor inputs. There was a lot of fucking noise.
Shut the fuck up.
I wish I had your algorithm.
No. So wait. Okay.
And I got some nonsense.
Okay, wait. Okay. So then my answer was the question itself. What question answers itself. The answer is what question answers itself.
Oh, okay.
So, but we're both wrong, right?
Yeah, neither of those things are particularly well formed. And
See, you suck too.
Not as much as you.
your intuitions about recursion and tautology are well founded. That's the direction you need to be thinking in to get a well founded answer to this question. And if you want to give it another crack before I tell you an answer,
I mean, I kept coming up with kind of versions of that, thinking about what is the question. I sat there like Harry Potter in the bathtub with my egg.
and you just never
Yeah.
dunked your head below the water.
I never
Just
dunked
like,
my head.
When she sent me the voice message, I was like, so if I were to spout off any tautology, it would be an example of this? Is that what this?
No, not any tautology will work, but that kind of thing is a good productive way to think about how to find solutions to this problem.
Okay. Well, yeah, that's so there. Does that mean I won?
So you want to hear the answer? And
Absolutely. Yeah. We tease each other all the time. So
this is not the answer. This is an answer. So what would you say if you repeated the phrase? What would you say if you repeated the phrase?
What would you say if you repeated the phrase? What would you say if you repeated the phrase?
There you go. That question is its own answer.
Then my question should count as well.
Well,
I
your
think you're just an amoeba. That's all I want to say.
Your question isn't well founded because, for example, the answer I gave would be a legitimate answer to the question you gave.
Ooh.
Wait, say this again. Say this again.
The answer I gave is a legitimate answer to the question you gave. So you asked what question would be its own answer. I could respond, what would you say if you repeated the phrase? What would you say if you repeated the phrase? And since my question is a question with its own answer, and not the only one, there are many, any of those are legitimate responses to the question you asked.
But you didn't say it had to have only one answer.
It doesn't only have one answer, but to be well-founded, the question should produce itself. And
it does, but it
the
doesn't
recursion.
only produce itself.
it doesn't only produce itself. That's
So-
what makes it not well-founded.
Okay, so what you're talking about here is the difference between like a virus is a good example of a quine because it only produces itself. Whereas, like our example, let's say an RNA virus only produces itself. But a DNA virus can go as a transposon into DNA and then be incorporated into DNA downstream into other entities. So then a DNA virus is not a perfect quine.
Yeah, well, like I said, amoebas are actually a better perfect quine because they have the internal capacity to actually do their own reproduction. The virus requires appropriate cellular mechanisms to hijack to produce copies of itself.
All right, Noah.
Okay.
Still better than Brett's stuff.
No,
That's hijacking certain cultural things.
Hijacker.
Effectively, any nonsensical word followed by a question mark would be frequently followed in English by the clarifying repetition of what was just said. So that kind of hijacky behavior, that would be a more viral version of a quine.
which makes my amoeba less a quine than an amoeba itself would actually be.
Right. You were talking about tautology and recursion. You'll note that tautology and recursion are both present in the response that I gave. And that's actually a critical thing to understand about quines in general, is that there's a necessity of self-reflection. And that, while they are still toys, is what elevates them to interesting toys, because self-reflection is a difficult task and something that mathematics is very much coming to grapple with since the 20th century and is core to what makes computers work.
And it's kind of the way that we look at science because we can't use science to examine itself.
Well, that's one of the big challenges that we're now encountering, because a lot of science is trying to become self-reflective and doing very, very badly at it.
Right.
Scientific production has dropped off by a number of measures over the last 50 to 100 years. And that's, basically disastrous in societies that depend on an oncoming stream of innovative access to reality.
That's an interesting thought I hadn't had before. Do you think that capitalism could come to a screeching halt by, I mean, obviously by finding the limit of Moore's law or the limit of scientific questioning and innovation? Do you think we've, reached this plateau like period where capitalism will have to respond to that?
So I think you're using capitalism the way I use industrialism there to describe the current organizational principles of governance, society, and economy. I would say that those systems have no future of any description, not because we've reached any sort of scientific plateau, but simply because they have been obsoleted by the introduction of computer technology, just as the pre-industrial systems were effectively obsoleted by the introduction of engine technology.
So we get techno fascism and techno feudalism now, is what you're saying.
I don't think either fascism or feudalism are going to turn out to be functioning social organization principles.
I didn't say it had to be
I
functioning.
think if we adopt them, I would expect that what we would get in exchange would be a dark age.
Absolutely. And that's kind of, I think, everybody's biggest fear.
Not everybody.
No, not you. Say more.
I don't see discussions of what to do now that we don't have anything that works and don't really know what working would look like being common currency. I talk about it, but that's just because I have a potential solution in the economic space. I don't have potential solutions for society or politics generally. Like I think of it kind of like a Maslow's hierarchy of needs type of thing, where hopefully if we can fix up the economy so it can work, we would have the resources and time to fix up the other issues as well. But unless everyone's willing to flush their cell phones down the toilet, I don't see a way for the politics, religion, markets, businesses, name an institution to survive in the face of the capacities of computers, because none of those things were designed to cope with those capacities. And we're watching them fail in real time.
Hmm. Yeah. Well, that's cheery.
But there's hope.
Sure. Well, so the fact that life itself is a computational process suggests that life is not incompatible with computation.
I would agree. A lot of times when people say, "Is the brain a computer?" This is a thing people love to ask me, and I love to argue that yeah, it is. We just don't understand it yet. What do you think about that question?
So, computer is a ridiculously general phrase. It would be nearly impossible for human brains not to be computers,
Thank you.
because the simplicity that a system needs to have in order to not be a computer is mind boggling. Stephen Wolfram, are you familiar with like Wolfram Alpha?
Oh, yeah. Yeah. Yeah.
He has found a computationally complete system which is expressible in, what is it, 6 bits?
Mm-hmm. Mm-hmm.
So that's insane.
Yeah.
Yeah.
Well, I think that people are framing the question weirdly. Like they're expecting a computer to be something much more complex than that when they pose that question.
Well, they're also expecting a certain degree of programmability.
Yeah.
And
Which we
that
have.
also, well, so that has interesting consequences. If a language or system existed to allow for the programmable manipulation of the human brain, what would be the consequences for a human brain to have knowledge of that system resident within it?
It's implosive.
Yeah, yeah. I mean, that's basically for the same sort of Quine reasons. Learning this information would probably cause a blue screen of death.
So that's where we're
I'm sure
at.
it's no coincidence whatsoever that we are so fundamentally unaware of almost everything going on behind every computation that we make in every minute interaction that we have with the world. There's a Lovecraft kind of quote, something like if the human mind were capable of correlating all its contents, like it would result in some utter insanity.
That's really close. I think it's in Call of Cthulhu, maybe, but I do not share Lovecraft's deeply pessimistic view of reality. And I think what computational science has offered us is a vastly greater capacity for measuring and understanding things quantitatively. And I see a very beautiful history in the quantization of the subjective. One of the classic examples that I trot out a lot is temperature, which, warm, cold, comfortable, uncomfortable, these are subjective things. And it was really only a few centuries ago that thermometers and the ability to measure, oh, that's 75 degrees, oh, that's negative 40 degrees, became a thing that could be done. But once we did have temperature measurement, then we discovered conservation of energy, industrial chemical processing, how to formulate engine efficiencies and then improve engine efficiencies, and basically got the modern world as a result of that.
So, as a mathematician, do you think that everything that is subjective is quantifiable?
Everything that's subjective is necessarily quantifiable. Just from the information theory breakthrough, information theory says that the information of anything can be broken down into the answers to questions that could be asked about the thing. So subjective experience is capable of answering questions. Those answers themselves are quantifiable. And in fact, since we can make those questions yes or no questions, and with a sufficient number of them, create the equivalent output of any more general question, every system is in theory fully quantifiable through some sequence of yes no questions. The difficult bits are what the contents of those questions could be, and how much time and in what fashion could the answers to those questions be extracted. Because you get things like, I can't remember the title, I think it's something like The Extraordinary Life of Tristram Shandy. He's a fictional character, and it's a novel length book, and he's writing his memoirs, and he almost gets all the way through his birth, because as he starts writing about his own experiences, it starts spiraling into
Mm.
other things.
Yeah.
And so, yeah, with recursive systems, infinity always lurks in the depths to destroy us.
There are a couple other authors too. I think there's so David Foster Wallace does something kind of like that, where he's using footnotes to describe the thought that he just described, which itself contains also another footnote. And so you've got this kind of infinite recursion, almost kind of like a fractality might be the right way to describe it. And there's another guy, I think it's Nicholson Baker, where he just talks about like he's sauntering through the mall and the kinds of excursions he goes on mentally as a result of little observations in the environment are just extraordinary. And so this book that probably would have taken him 3 minutes to do, it takes you 5 hours to read.
Right. Yeah. And this shows up in other contexts as well. It just occurred to me, the Balrog scene from the Lord of the Rings movies. Before they get to the Balrog scene, which was sort of very well scripted, there's the big action bit where they run down the stairs and the stairs collapse out from under them and they're having an arrow fight. Apparently, in the original script, that scene was party runs down the stairs or fellowship runs down the stairs. And then as part of the process of making that film, they spent years doing previs. So they were drawing up little pictures and the animatics and stuff like that.
Mhm.
And so Jackson gets to this bit of it and is like, well, that's a little boring. It needs to happen. They have to get from here to there, but let's spice this up. And so they put some orcs over there for them to fire at. And then they were like, well, that's cool, but they can just run away. So let's like give them something. And so that that still appears in the script as fellowship runs down the stairs.
And then that fractalized into Rings of Power. They wouldn't have the Balrog scene or any of the backstory to even concoct this entire series.
Yeah, that series only exists because the Jackson films were successful and as big as they were. Yeah.
Well, I mean, I would even say the entire series really only exists in the success that it's having because of that particular expansion of that scene.
That's what they closed off the trailer with, as I recall.
This kind of gets me because I think about Our very first episode of this podcast, we talked about quantifying the qualitative and intersectionality and all these kinds of things, how they basically want to quantify their level of oppression, people who are into this kind of thing. And I'm pretty sure it's probably quantifiable, but much like what you're talking about, it's all recursive and almost inestimable in our current thought process because we can't ever really understand, oh, I had food insufficiency, I have celiac disease. It goes on and on and on and on and on.
So this gets into the basic structure of what we can and perhaps should build around our societies. We've been leaning basically fully supported on the fact that complexity could more or less only come from other human brains. And well, some people are smarter and some people are more energetic and some people are more ambitious. There's very low limits compared to what's possible in the universe on how much of any of those qualities can be expressed by any person or group of people. But we've got machines that do that stuff now. And so we're now coping with what the universal limitations are. And human scale analogies are wholly insufficient for what's going on. And that's where it gets into things like my system is 300,000 times more efficient than the market system's algorithm is. And that's, in algorithmic improvement terms, not a big one.
Well, there's also an exponentially larger number of inputs into this societal computer.
True. So when I say, this 300,000 fold improvement is relatively small, what I'm saying is that the gains from algorithmic improvements in many cases are on the order of 1,000,000x or greater. And that's because what algorithmic difficulty is mostly about is something called the big O notation.
Oh, really?
Yes.
I'm going to go have a cigarette.
Yeah, there's small O and there's big O, and big O is a little easier.
It's true. There are small O's and big O's. Yeah.
That's right. So let's say you're trying to look up a word in Charles Dickens' Great Expectations. How would you do that? Well, if you don't have a page number reference, you just read until you got to the word. Let's say you wanted to look up the same word in the dictionary. Well, the dictionary is sorted, so you would use that sorting index to try to get to it. Looking the word up in the dictionary, which is pre-sorted and has indices, is a logarithmic search. Looking it up in a novel is a linear search.
And then looking it up on Google.
Google is doing logarithmic searching stuff for you, basically. If Google's algorithms were stuck doing linear systems, then their costs would increase by factors of trillions, and they wouldn't exist.
Do you think that mathematical intelligence is entirely encompassed in G or IQ, or do you think there's some of it falls out and it's not all captured?
Mathematical intelligence is the part of intelligence that correlates most strongly with G, but I think of rather more importance from a historical perspective, there are close to zero examples of intellectual contributions to human well-being that were not mathematical productions. There's a few hopes for people that aren't math brains. Faraday wasn't a mathematician, and he figured out nearly everything about electricity. But from Archimedes and block and tackle to modern crypto systems, which turn out to be wholly dependent on the interested fantasizings of number theorists of the 19th century, math keeps being real and keeps being useful through the generations, and basically everything else falls away.
But that's not what I asked you.
But that is probably the right answer.
So G is an extracted statistical measurement that correlates with social success.
So do you think it's possible for someone to have a lower IQ or a lower mathematical G correlate and still have mathematical intelligence?
It definitely might be that there are, I guess there's the famous case of Feynman, who's one of the most mathematically intelligent persons of the 20th century, who supposedly had a recorded IQ of 127. But like that's a rumor. I certainly never gave the man an IQ test. And there's another point. G is also a group measurement, which is an odd subtlety that I don't see people bringing up very often. So IQ was mostly developed in sort of management, like, you know, armies management, that HR type contexts. And so a team of people with, you know, like if you're going to have a tug of war and one side of the tug of war is professional athletes and the other side of the tug of war is college athletes, you probably want to bet on the professional athletes because they're probably more elite. If you have two teams of people working on stuff and one has an average IQ of 105 and the other an average IQ of 106, you probably want to bet on the team with 106 because that's sort of what it was designed to do, is to figure out who to put on your good teams. If you have a person with 105 versus 106, you're losing a lot of fidelity there, and it becomes a lot more of a coin flip.
If you look at the annals of history, you hear one name, one individual. So this is completely counter to what you're saying. I mean, we all know the saying, two heads are better than one. You know, it takes a village, all these sayings that are talking about a communal intelligence. Moving forward, people are thinking more collectively. We've gotten so individual in our society, and we're focusing so heavily on success correlated to IQ, and these kinds of things are such an individualistic thing that I think a lot of people are starting to think more communally. Like, okay, so maybe I have a 106 IQ, but like, you know, maybe you've got, you know, a 140 IQ. And then we were working together, and the output of that could be even greater than just you alone with your 145 IQ or whatever.
Oh, so are you familiar with James Burke's work, Connections? He's a historian, and he's written a few books, one called The Pinball Effect, which is sort of a networked history book where each event has like a footnote attached to it of the influences that helped that event occur, and then the things that that event's occurrence influenced. So you can jump around through the history of science. And so that's one of his bugbears, is that while individual geniuses definitely exist, Newton's sort of standing on the shoulder of giants thing is also a common part of the fabric of the gain of human knowledge. And if Newton had to invent glass grinding and glass blowing in order to do his own observations, like he never would have had time to get to calculus because he would have died of silicate inhalation. I view marketplaces as a system and process that has allowed large numbers of brains to work on the problem of where the economy is headed. And that's better than a command and control system where whoever's in charge of the army or whoever's in charge of the Bureau of Farms decides where the economy is headed.
But the problem of marketplaces is that large parts of these corporations are owned by individuals.
So yeah, but that gets to the heart of what it will take to build systems that aren't going to destroy us, is figuring out what is of value in having a digital cultural space. Maybe the answer is nothing. It might be so dangerous for people to engage with each other semi-anonymously that we're better off not doing it at all.
And there's lots of evidence pointing in that direction.
Currently, there's a lot of evidence pointing in that direction. On the other hand, currently, all of those spaces are curated by creepy weirdos who came up with the idea for them in their dorms. So this will come out in 2023.
No, this is coming out Wednesday. I have to edit all of this shit together. Oh my gosh. Like this was so fun. Thank you, Noah. I appreciate you.
Thank you so much. Really good conversation.
Great. Bye-bye.
Bye.
Bye-bye. Take care.
We made it.
Woo.
Thanks for playing with us. For more information on Noah, his CDM system, and to see what the heck happened behind the scenes this episode, make sure you subscribe to the Theory Gang newsletter at theorygang.io/newsletter.